some point. So, well, you never know. If you know that you're going to be out Tuesday, you're welcome to take both parts on Monday. You can always come to my office. God bless you. Those of you who need help today, I do not have any plans after 10 o'clock today, so I will be in my office guaranteed. I don't think I'm going to get called in to chat with the superintendent again and all those people, but it was all a good conversation. Loved it. Do what now? No. All right. So Monday, Tuesday are tests. Now let me ask you all this. If you were to go and plug data into your calculator because there's some word problem given, and I were to say, I want to know what the r-squared value is if it's linear, the r-squared value if it's quadratic, the r-squared if it's trinomial, r-squared if it's quartic. Can you do that? Yes. Okay. So all I'm looking for, what is the r-squared value necessarily going to tell us? What number? The correlation. So what number do you really want to get as close to as possible? 1. So if you had an r-squared value, so after that, if I then ask you a question, write the equation that has, which would establish the equation best fit. And let's say the linear correlation was like 0.25, the quadratic was 0.36, and the trinomial was 0.97, and the quartic was 0.85. Which one am I going to use? The trinomial, okay? And then, if I were then to ask, what would you expect for a value to be inside the data? How can I do that? Plug it in. What is it? Calculate, trace a value. Okay, so you're plugging a value in. Okay, you would also have to have that graphed. So sometimes we have found, and I still haven't gotten to the answer that I want yet, some of the calculators are getting goofy when you do the y equals var statistics equation, enter. For some reason it gives too much of an exponent. So you might have to write down the equation, I think for each, or I think the one that says write the equation of the line of best fit. I think I said round to 3 or 4 decimal places. So if you round to 3, I forget if it's 3 or 4, but if you round to 3 or 4, like I said, you plot it in on the calculator by hand, you will easily be able to get the traceable value. Okay, that make sense? So that's the only thing that we won't have on the review itself. So just, all you're doing is plotting data, looking at, you're figuring out what the r-squared values are, writing the r-squared values from linear to quartic, and then you're determining which one of those would be the best equation, writing that down, and then you're finding a point that would be, what would you expect at this year, what would you expect it to be? So that's that only region. On this, and then also tomorrow, I photocopied the test, and I think I have 3 or 4 different colors the test is in. So if you have a pink one and your friend has a blue one, they're the same test, just on different colored pieces of paper. I don't know who thought it was funny to mix up the colored paper in the printer, but I wasn't going to go, I'm just going to throw all this away and then start over again. So if there's going to be different colored tests, don't worry. If your friend has a different color than you, you still have the same printed material, just not a different color. So, because if I didn't tell you, this is what would happen. Alex is not here today. He would for sure look over and say, oh, look, they're the same. And then he would announce it to the entire class. Dude, they're both the same. And the reason he would have known that is because, he's from Parker. That's how the kids from Parker are. And then 3 people that have to share each other going, hey, look, yeah, they are the same. It's like, I just want to let you know, I didn't put it on different paper, trick you. No games being played. It's just that's not one card. So it's 8:45. It's 8:30 now. 8:45. All right. Problem number 1. They want us to solve it, right? Or factor it. So we have 4 terms. You have to think about factoring by parts. So I have this portion I'm going to factor. and this factor. Okay? My greatest common factor on this first part is going to be x squared. That's going to leave me x plus 1. And then, usually, if you have 4 terms and you're factoring by parts, or factoring by grouping, if your third term is negative, usually it has to be a negative you factor out. So I'm going to go ahead and factor negative 4 out. If I factor negative 4 out of that, I'm left with x. Negative 4 out of that becomes plus 1. So we went from 4 terms down to 2 terms. The 2 terms are the red and blue. And I have these in common between the two, so that gives me x plus 1. And then I have x squared minus 4. So x squared minus 4 is the same thing as x plus 2, x minus 2. And so my solutions are negative 1 because of that. And that's going to give me a negative 2. And then this one's going to give me a positive 2. Okay? So before we do the end behavior stuff, the graph, this is positive, so it's going to come up from the bottom, change directions and head up. Okay, I guess you could mark down here being negative 4. I'm not necessarily looking for that. So as x goes to negative infinity, where does this go? As x goes to the left to negative infinity, where does the graph go? Negative infinity. And then on the next one, as x goes to the right, so as x goes to infinity, where is the graph winding up? Infinity. And that's a whole problem right there. Okay, you can see that on a non-calculated portion or a calculated portion. It could go either way. May I move on to the next problem? You're good. And I do have it recorded, so you guys can always go back and watch it if you need to. Good? All right, next problem is just talking about end behavior. So that means it's going to, both ends are going to go to the same spot. This means they're both going to go down. So this is what our graph would look like, something like this. So as, for some reason, okay, so as I go to the left, where is my graph going? As I go to negative infinity, where's my graph going in the y direction? Negative infinity. As I go to the right, as I go to positive infinity, where's my graph going? Negative infinity. It opens downward. This one's going to look like our other graph, like this. So as I go to the left, to negative infinity, where's my graph going? Negative infinity. As I go to the right, so as I go to infinity, where is this going? Positive infinity. That's really all you'll have to do on that. If you flip-flop this, if you had this one being the negative infinity, this positive, that's fine. You don't have to have it in any particular order. Obviously, the negative infinity has to go with its end. The positive infinity has to go with its end on those kind of problems. Can I move on? That would be more likely on the non-calculator portion. On problem number 3, they wanted us to tell if they're giving us one of the solutions, so we have to verify it's a solution. So I'm going to use my synthetic division. So I'm going to go negative 3, upside down division. So I have a 1. Make sure I don't have any holes, meaning any squared terms that are there. All right, so I'm going to bring this straight down. That's a 1. 1 times negative 3 is negative 3. Adding those, that's negative 1. Multiply, that's positive 3. That becomes negative 2. That becomes 6. That becomes 0. Okay, if I divide something that's a third degree, what does its answer become as a degree? Second degree. So this is now an x squared term. So this is the same thing as saying 1x squared or just x squared minus x minus 2. So I can either factor it or use the quadratic formula. Okay, factoring is going to work if it truly will factor. Quadratic, go to from there. So what two numbers multiply to give me negative 2, add to give me negative 1? I'd say negative 2 and positive 1. So what are my other two solutions? 2 and negative 1. Are these real or complex? Real. Okay? you usually cannot factor something that's complex. If you use the quadratic formula on it, if you had a negative under the radical sign, then that's going to be your complex solution. Does that all make sense so far? So I'll give you a 0. Each time you divide, it will lower your exponent. If it gets down to an x squared term, then you can either factor it or use the quadratic formula on it. May I move on? We good? Problem number 4. Okay, so what would the degree of this be if I multiply the whole thing together? 5. I have this 4 times and I have this 1, so if I FOIL it all together, it would be a 5th degree polynomial. Okay? I'm not asking you to multiply the whole thing together, though. My leading term. So the only thing you're looking with the leading term is if this and this happen to be something other than just x, then you have to kind of do the multiplication. But then you look here. So my leading term in this case is going to be negative 2. What's the multiplicity of x minus 3? 4. Would that bounce or go through? Bounce. What's my multiplicity of x plus 1? Or excuse me, x plus 2? 1. Does it bounce or go through? Goes through. That's all you're going to have to do on that problem. I think on the test I actually knocked out the leading degree. I don't think you have to do the degree, I think. No, the degree you'll have to figure out. So this is a 4 and this is a 1. So if you multiply the whole thing out, you'd have x to the 5th power.
Oh, okay.
You know, something x to the 5th power with a whole bunch of extra. Almost done. Can I move on? Are we good? Did someone say not yet?
I said yes.
Okay. All right. So problem number 5, this is all I'm looking for. Graph this. This kind of looks like this. Still with me?
Yeah.
Now I'm going to graph this one. Does this one flip over the x-axis? No. Does it flip over the y-axis? Which way does it shift, right or left? Right. Right. How many? 4. So this point's going to go 1, 2, 3, 4. Okay? Is it going to shift up or down? Up. So then I'm going to go up 1, 2, 3, 4, 5. And so that's basically what that graph is going to look like. What about if I had this graph? Does it flip over? Okay, so it flips over the x-axis or the y-axis? X. So it's going to flip over. So it's going to look opposite of this. Does it shift right or left? Left. So I'm going to shift left 1 and then down 2. So this point and this point is the same, but then the graph is going to look like that. So the one on the test, I believe, you have to say it will shift over, or it will flip over the x-axis, or it won't ever flip over the y-axis as far as this class goes. It shifts right or left, shifts up or down, however many.
That's flipping over the x-axis.
The hard thing is it's 3rd degree, so it looks like it is actually.
Okay.
But because the negative out front, the only way it flips over the y-axis is if that's a negative right there. Okay? But it's hard to see on a 3rd degree if it's flipping. Okay? Almost done. Number 6, horizontal asymptote. Degree on top, degree on bottom are equal. What's my horizontal asymptote?
3/5.
Y equals 3/5. Okay? So if they are equal, then you take the lead coefficient over lead coefficient. Degree on top is less than degree on bottom. What's the asymptote? Y equals 0. Degree on top is larger than degree on top is larger than the degree on bottom? None. But this would probably have an end behavior asymptote. I'm going to get down with number 7. Can I move on? The oblique. So I'm going to go x plus 2 divided into 2x to the 3rd plus 4x minus 1. Notice I don't have an x squared term, so we might have to keep that in mind. I'll finish this one tomorrow. Have a great day, everybody.